All right, so we just finished placing our pixels or our detector array, which was 3 by 3 detectors using a single logical volume and multiple physical volumes, and having a different copy number for each placement. And I just noticed that I didn't change the physical volume name, so let's just change that to phys px, or physical pixel, which is similar to dx, but we'll just keep it like that. So, and just a reminder, we had this pixel copy number and we had it placed so it would go 0, 1, 2, 3, 4, 5, 6, 7, 8. And now we want to get the work towards being able to score all the energy deposition or dose scored in each one of these volumes in a simulation and output that energy deposition or dose. So I'm going to show you the more simple method to follow using the stepping action, but just to point out, the stepping action isn't the most efficient way to do it. If you were actually doing a serious simulation, you'd probably want to consider using the sensitive detector class, which I might cover in a later video, but the same principle applies to the stepping action as it does to the sensitive detector. So I've opened up my stepping action class already, and I've got this command or variable, sorry, set to the copy number, and all this variable does is it accesses a step, as you've probably already seen in previous videos, and it gets step, accesses step, and then it, with accessing the member function of the step class, it gets pre-step point, and then it gets this touchable handle, and then it finally gets the copy number, or calling the get copy number function. And so it's a bit of a mouthful with the different functions which are called on top of one another. But once you get this, you should get the copy number of your volume in question. So, and just to point out here, this 0 here, it relates to the layer that you're retrieving from. So actually, I think that PDF has a good slide in it. So yeah, so if you had, so in our case, we've got a single volume that these detectors, our pixels are placed in. But if we had a situation like this, where we had, let's say we had our arrays in this logical volume here, this blue one, and we had our 9 volumes placed in this single blue volume, then if we placed this blue volume multiple times like this, then if we wanted to get the copy number, we would have to specify what layer of the copy number is. So if we wanted to get the copy number of this volume itself, then we'll just have to say get copy number 0. But if we wanted the mother's volume, then we'd have to specify the level 1, so like the copy number above of the mother. So just now, you might never use this different layer. You might just always have just one layer of placements. But if you have like multiple layers of mothers, so if you have like one mother volume and you place multiple volumes in that with different copy numbers, but if you place that mother volume multiple times and you want to access, if you care about the copy number of the mother or the daughter, then you might have to change this layer. So, and this is particularly important if you have a voxelizer phantom, which again might be some later video, but for now we just care about the copy number 0. So what's the copy number of the volume I'm in now directly? So I'll place that in my stepping action. So let's just, and I've got it to spit out the copy number of every volume that the track passes through. So let's just visualize our volume. Let's open our biz.mac and our Geant4, so a good old geometry particle, you could call it, and let's just copy some of these options into our biz.mac, so when we run it, it has all these options set for the Geant4. So run beam11, let's just comment out that line, and I'm going to change it so it's just a point source, and I'm going to change the starting position to be -3 centimeters. So remember our repeated volumes we're placing are 5 centimeters cubed, and it's placed at the center, so it goes between -2.5z to +2.5z, and let's just have it starting at 0, 0. So we're just starting just before the origin, and we're going in the positive z direction, and that should be enough for now. So we can just close that Geant4. We won't be using that again. So let's just change it, because I changed the volume in the detect instruction. So if we just run in interactive mode and zoom in a bit, and let's shoot a Geant4 now. So just run beam on 1. So see the Geant4 started just before the cube or detector volume. So if we look at our track, primary was a Geant4, started at 0.30. So the first volume is the fizz box. So this water volume here, the large white one, and then you can see it then forced a step in the pixel, our fizz px, so physical pixel, and you see the copy numbers here. So this is every copy number that's being placed in. So our copy numbers of our volume is 0. Oh, that's for our. So here where we've got our, since we're doing the pre-step, so when we leave the volume here, so when the Geant4 hits the volume here and exits, then we get its pre-volume ID. So this 4 relates to the pre-volume. So once it's exited, its pre is the pixel volume. So that's why we've got a copy ID of 4. And if we wanted to just check the pixel volume, the copy number system, we could just shift the starting Geant4 position. So let's just put that into the interactive session interactively. So let's just copy this command, and let's change it starting from 0, 0 in the XY to, let's shift it up by +3 in the Y. Oh, sorry, not 3. We want by 10, because the spacing's 10 from the center. So we just shot from Y = 0. So let's now shoot it Y = 10. So let's just change that position and run it again. So see, we're now shot the beam higher up. So if we check our output, we should have a different copy number. That we do. So 5, because remember it goes 0, 1, 2, 3, 4, 5, 6, 7, 8. So we just went up volume above here, and if we wanted the copy ID of 0, then we'll just have to move the volume to -10 for the X and the Y, I think. Let's just quickly check that. So yeah, that is where we were hoping it would. So if we just look at output, we see copy ID is equal to 0. So we've just seen how we can actually access the pixels or the copy ID, and I think I'll just stop it here and just show how we could actually score it conceptually in the next video.